Okay, chapter 10, circle basics, lots of vocabulary. So a circle, it's a set of points equidistant from the center. In my picture over here, we have circle C. It's labeled with the dot in the very center, and it's labeled with a capital letter, so that's circle C. A chord is a segment with endpoints on the circle, and in the picture, it's chord AB. I want you to pay attention that this is a segment, which means that it has two endpoints, whereas a secant is a line that cuts the circle at 2 points. The difference between these two is this is a segment, a chord is a segment, and a secant is a line. Really important that you see the difference because they do look very similar. Here's a chord, here's a secant. Really important that you see that because if I asked you to look at that picture and tell me, give me an example of a secant and you wrote the notation this way, it would be wrong because a secant is a line. So going back to chapter 1, a segment is just two capital letters, any 2 points on that or the two endpoints on that segment with that line across the top. A line goes on forever in opposite directions, and you name it with any 2 points on that line with a line with 2 arrows at the top. So please make sure you use a correct notation for either of those. Tangent, it's a line that touches the circle at 1 point, which means it never goes inside the circle. So this brown line, GH or GF, any of those 2 letters we can label with because it's a line that goes on forever. It touches the circle at F. So F is the point of tangency where it touches it. Make sure you know all of these terms because these will be important when you do your project. Moving on, congruent circles, they have the same radius. So if you think about other shapes that we've talked about, rectangles, rhombus, there's lots of different parts to them. There could be the height, the bases, the diagonals, lots that can change from one size to another. With circles, the only thing that can change is the radius. Circles always look the same, whether it be a really little small circle or a really big circle, they always look the same. The only thing that can change is the radius. So if the radius are the same, then we can guarantee that it's a congruent circle. Tangent circles, they share 1 point. If you think about what the word tangent meant a minute ago, it only touches the circle at 1 point. Tangent circles only share 1 point. That should make sense. Concentric circles, they have the same center. So I'm not a perfect circle drawer, but this point is the center of the smaller circle. This point is the center of the bigger circle. They share a center. It's almost like a target, if you want to look at it that way. Common tangents. It's a line that is tangent to 2 circles. I have 2 examples here. So this tangent is a common tangent between these 2, and it's considered an internal or inside tangent because it goes down the middle of these two circles. This one's a common exterior tangent because it does not go through the middle. It just stays on the outside of those circles. So if it's tangent to 2 coplanar circles, and what does coplanar mean? Does anybody remember that from chapter 1? What's coplanar?
On the same plane.
It's on the same plane, good. So 2 circles that are on the same plane can have a line that's tangent to it. So we have 2 new theorems. This is one new theorem. It says a line is tangent to a circle if and only if the line is perpendicular to the radius of the circle at its endpoint on the circle. First of all, what does this mean? This is good review for you. What does IFF mean?
If and only if.
Okay, give me more. What does if and only if mean?
It means if something, the other is only if that thing is true.
True, but I want more. There's a little bit more to it that we learned.
It has, the second part has to be true if the first part is true.
More. Kate? It actually does. Did you say doesn't? It does. So going back to chapter 2, if and only if meant this. It had an arrow both ways. I think that might be what you're thinking about. What that means is the conditional, if P then Q, and the converse, if Q then P, must both be true in order for that if and only if by conditional statement to be true. Remember that?
Yes.
So what that means here is that it works both ways. So if a line is tangent to the circle, then the line is perpendicular to the radius. If the line is perpendicular to the radius, then that line is a tangent. It works both ways. You can flip-flop it. That's important that you see that it works both ways because we're going to be using that for both of our examples. So looking at my picture, here's my radius. This is the center. This is a point on the circle, so that's my radius. Because it's perpendicular, we know that this is a tangent line. This is a tangent line because it's perpendicular to the radius. Looking at my first example, it asks us to figure out if DE, which is this line on the outside, we have to figure out if DE is tangent to circle C. If it is tangent to circle C, we would know that this is a right angle. That comes from this theorem that we just talked about. We need to figure out if that's a right angle. We're going to concentrate on this triangle that's drawn for us to figure out if it is a right angle. Remember Pythagorean Theorem?
Yes.
That's what we're going to use. So this triangle, let me kind of redraw it for you. This is 3. This is 4. What's that hypotenuse length?
2.
What's the hypotenuse length?
5.
Good job. Where'd 5 come from? Hold on. Where'd 5 come from?
The radius is 3 plus the 2.
Be careful. This is an important idea because you'll need this more than once. Let me use a different color here. So they already gave you from here to here is 3. Well, any spot that goes from the center to the point on the circle is definitely going to be a radius. So here to here would be 3. Anywhere from the center to a point on the line would all be 3. So because this is 3 and this is 2, the entire hypotenuse is 5. Do you guys see that? That's important to see. Does anyone recognize this as a Pythagorean triple? Back from our previous chapters. Okay, if you do, that's great. If you don't, it's good practice to know how to do this if it was a harder problem. So we want to know if the Pythagorean theorem works. If it works, that means both sides of the equation will be equal, which means it's a right triangle. Remember that from previous chapters? So I'm going to plug it into the Pythagorean theorem and see if this is a true statement. Whoops, I meant to write 5 squared. A squared plus b squared, we want to know if it equals c squared. 9 plus 16 gives me 25. 5 squared is 25. Because it works, meaning that the equation is equal, that means that this is a right triangle, which means this is a tangent line because it is perpendicular to the radius. So all of this work and this understanding for an answer of yes, DE is tangent to circle C. Example 2. It tells us that ST is a tangent to circle Q. They want us to find the length of R. So because ST is a tangent, I know that this is a right angle. Because it's a right angle, I'm allowed to use the Pythagorean theorem. I'm going to do this one on the TV because I know you guys are going to have a hard time seeing this. So here's my triangle. This side is 24. This side is R. What's my hypotenuse? What's the length of that? 18. R plus 18, good. Remember, you're adding. So we're going to set up our Pythagorean theorem. We have to be careful because it's a little more complicated this time. And we're going to figure out what R is. So these two are my legs. Remember, the hypotenuse is across from your 90-degree angle. So it's going to look like this. R squared plus 24 squared equals R plus 18 squared. You cannot just apply that 2 to the R and the 18 because of that addition problem. You have to actually FOIL this problem. This is good review for you guys. So you're all doing this with me, right? Okay, let's start simplifying. Anybody have Desmos open? I need 24 squared. Thank you. On this side, I'm going to rewrite this because I want to review foiling with you. Anytime you have an addition or subtraction problem in there, you should rewrite it so that that helps you remember you have to FOIL. So let's go through our foiling. So first, outer, inner, and last. your first or the two first terms. So what's r times r?
R squared.
R squared. Maybe if I use colors, this will help. Outer, r times 18, what does that give me?
18 outer.
R times 18 gives me 18r. Inner, 18 times r, what's that give me?
18 outer.
18r. And last, we'll use this one. 18 times 18, what does that give me?
324.
Thank you. Questions on the foiling part of it? So I know you guys had questions last time we did it. First terms, outer terms, inner terms, and last terms. I would say probably 80% of the time, these two middle terms can be combined because they have the same terms. They both are just plain r's, so we can't combine them. So my next line of work, let me just bring this down, just keep myself organized. My next line of work is I'm going to simplify that. So 18r and 18r gives me 36r. Okay, so I FOILed and I combined. I didn't move anything yet. Anytime you have an exponent like this, you kind of have the idea that you might have to factor. So keeping that in mind, move everything to one side to get ready to possibly factor. So I'm going to move everything to my right side. First thing I'm going to do is subtract my r squared to move everything on one side. When I do that, what happens to my r squareds?
We cancel each other out.
They're gone. When I subtract r squared here to move it over, they both cancel each other out, so those are gone. I'm going to subtract my 576 and put it over here. What's 324 minus 576? Say it again. 252, right? Now in this particular problem, we don't have to factor. It ended up canceling out and making it nice and neat for us. If you ever did have to factor, this is where you would have to factor it out. But anytime you see squareds, that's a good practice to get everything on one side. So I'm going to move my 252 over. I need 252 divided by 36. What does that give me? 7. Thank you. You should always do a quick check. Does it make sense, looking at my original problem over here, that the radius could be 7? Seems like you should always do that. If you got an answer like 3,000, I think that'd be a little bit of a red flag, like, that doesn't seem right, maybe I did something wrong. So always do a quick double check. Okay, one last example over here with our new theorem. This theorem says tangent segments form an exterior point are congruent. So these two lines, RS and TS, are tangent segments. Because they meet at an exterior point, that means that RS and TS are congruent. So two tangent lines, they meet at an exterior point, they're congruent. Looking at my example here, I know that these two blue lines are tangent. They meet the radius at a perpendicular, they meet the radius perpendicular. That means that these two segments, this segment and this segment, have to be congruent using this theorem. So because they're congruent, I can set them equal to each other and solve. How do I solve, or how do I get rid of that little 2?
You square both sides.
How do I get rid of it? Square root. Square and square root cancel out. What's the square root of 9?
3.
And?
Just 3.
And? What did you say? You got it. It's positive or negative 3. Be careful. Both of them will work. Think about what we just said. I asked you guys what number, when you multiply by itself, will give you 9. You're right, 3 does. But don't forget, negative 3 will also give you 9. Because negative 3 times negative 3 gives you 9. Positive 3 times positive 3 gives you 9. Both of those answers are correct. Okay.